Hello student, this is Ashish Vegadwa from Electrical Department. Today we will learn Chopper Part 2 in the subject Power Electronics. Let's move to the content of this topic. In this topic we will learn Type A chopper, which is a first quadrant chopper, and the next we will learn Class B chopper, and it is a second quadrant chopper. So let's start with the Type A chopper or first quadrant chopper. So this is a circuit diagram of type A chopper. So we have connected one switch. As a switch we can use various devices like SCR, BJT, MOSFET, IGBT, etc. Basically we are using SCR as a switch. It is connected in series with the load and across it having one freewheeling diode. Input voltage is Vs, the output voltage is V out, and the current will flow from the input to output, and it is a load current. It is indicated by IO. And this is the characteristics. And the class A chopper is step down chopper. It means we will get output voltage is lesser than the input voltage. On x-axis we have taken current and y-axis we have taken voltage. So it will operate in first quadrant. So this is the waveform of class A chopper. First we will see various theory of this chopper and later on we will understand it from the diagram. So when chopper is on, the supply voltage is connected across the load. When the chopper is off, it means the output voltage will be zero, as of no current will flow from the input to output, and the load current will continuously flows in the same direction through the freewheeling diode. Why freewheeling diode? Because load having inductor and the energy of this inductor will be dissipated through this freewheeling diode. The average value of the output voltage and the current is always positive because the current will flows from input to output. And the same time, sign of the output voltage will be positive and negative will remain same during both of the operation when the chopper is on or off. Class A chopper is step down chopper in which power will always flows from the source to load. Generally, it is used to control the speed of DC motor. Suppose you have used one DC motor. So, if you control the supply voltage which will be given to this DC motor, then the speed of DC motor will be changed. If we reduce the voltage, then the speed of the motor will reduce. The output current equation can be obtained in step down chopper with the RL load can be used to study the performance of class A chopper. So as per this circuit diagram, we have taken three waveforms. The first one is gate pulse, second one is load current, and the last one is output voltage. Now if we apply the gate current to this SCR, then the switch will be turned on. Here we have shown that when switch will on, this diode will remain reverse bias. So current will flows from the input to output and it will try to increase. So current will increase from the some value to the maximum. And the same time we will get output voltage is equal to the input voltage, and it is a turn on time of the chopper. Now if we turn off the chopper, it means if we remove the gate pulse from the switch, then the chopper will be turned off. Now the current will try to decrease and the load having inductor, so current will decrease from the maximum to the minimum value. As of this freewheeling diode will become forward bias and it will short the load, so the output voltage will be zero during turn off time. In class A chopper we will get output voltage is always less than the input voltage. During turn on time we will get output voltage. During turn off time we will get zero voltage. Let's see the next chopper, that is a class B chopper or second quadrant chopper. It is a step up chopper. It means value of the output voltage will be greater than the input voltage, that we will see from diagram. In this chopper, load contains a DC source like a battery, and this battery is chargeable. It will drive the current through the inductor and resistor in the direction opposite to the shown in figure. When the chopper is on, the inductor will store the energy inside. Now if we turn off the chopper, the diode will be forward bias, and same inductor having stored energy which will return to the supply. And average output voltage is always positive and the average output current is always negative, and the current will flows from the output to the input. It means motor will operate as a generator. In this chopper, power flows from load to source and the output current is always negative. This kind of chopper is used for regenerative braking of DC motor. During this mode, motor will operate as a generator and it will try to reduce the speed of the motor as the braking will perform. It is a step up chopper. Let's see circuit diagram of class B chopper. So as per this circuit diagram, we have one load. As a load, we have taken one inductor and one battery source. Why battery source? Because in this kind of chopper, we are using motor as a generator. Same, having one diode, it is connected from load to source, and across the load we have connected one chopper we have connected one switch. Output voltage is V0 and the input voltage is Vs, and this chopper is operate in second quadrant. So the output current will be negative and the output voltage will be positive. This is the waveform of type B chopper. It having total three waveforms, that is gate current, output current and output voltage. Now assume that the chopper is on such that current will flow from the load to the inductor to the switch SCR, and current come back to this negative point of load. At this time the switch will operate as a closed switch such that the output voltage will be 0 and the current will try to decrease. Now if we turn off the chopper and turn off the SCR, same time when the switch is on, this inductor is going to store energy inside. So when the chopper will be off, at that time the EMF will be induced in this inductor and the energy stored in this inductor will be dissipated through this diode into the supply. So power flows from the load to source. It will flows from the load voltage to the inductor to the diode to the supply voltage such that the output voltage will be greater than the input voltage and current will try to increase. When the chopper is on, output voltage will be 0, and when the chopper is turned off, it means SCR is off, the load will discharge through this diode and it will charge to the supply voltage. At that time output voltage will be greater than the input voltage to make this diode in forward bias. So as per the waveform, we will get 0 voltage when the chopper is on, and we will get input voltage is greater than the output voltage when the chopper is off and the diode will conduct due to energy stored in this inductor. Let's see question for assignment. Explain class A chopper. Explain class B chopper. Thank you.
If you like this video, please subscribe and like our YouTube channel LJP Electrical, and don't forget to click on the bell icon to get latest video update fast.